Thank you very much, Magoso-san, for your kind introduction for me. You really know about you're good at Japanese, I believe so. Anyway, and first of all, I'd like to thank Dr. Sundaram and the organizing committee of this meeting to give me the opportunity to attend this wonderful palm oil congress. And I'm very happy to be back to your country here. And yes, let me start, that's right. And Lion Corporation is a home product maker, and our major product is detergent and softener and soap. And we have been using the palm oil as a raw material for these products. And we are imported crude palm oil from your country, and we have the factory, and Sakaide is a Shikoku Island, it's the west part of the Japan, and we also have we are converted palm oil to the methyl ester using this plant. And we also have the plant to purify the palm fruit carotene using a HPLC system, and we could obtain the purified the palm fruit carotene, and this palm fruit carotene is resuspended to the edible oil at the concentration of the 30%. And we are selling these palm fruit carotene as a raw material for the food colorant or ingredient of the functional food. As you are well known, this slide shows the constituent of the palm fruit carotene, and the palm fruit carotene constitutes 30% alpha carotene and 60% beta carotene and 55% other carotenoid, gamma carotene, and lycopene, and so on. And this slide shows a major biological function of the carotenoid. And among these applications, we could find out the fascinating biological activity of palm fruit carotene against antioxidant activity or cancer preventing activity. Today, I will introduce you our application data on these two areas. And as a first part, I'd like to introduce our data on the effect of oral administration of palm fruit carotene on UV-induced skin lipid peroxidation. As you know, and the distinct point of anti-cancer and antioxidant activity of a carotenoid is that carotenoid have the strong singlet oxygen quenching activity as shown here. And compared with the vitamin E or the vitamin C, carotenoid have the stronger quenching activity. And as I mentioned you, and the palm fruit carotene has a carotenoid, contain the carotenoid, and which have the strong singlet oxygen quenching activity, lycopene, gamma carotene, and alpha carotene, and beta carotene. And as you are well known, and oxidative damage rule of the singlet oxygen in our body is still not clear at this stage. But you know, our skin is contain the large amount of polyphenol, so that we are illuminated in the strong UV light and in the sunny day, and the skin would be generated excess amount of singlet oxygen, and the skin lipid would be peroxidated. And one of the interesting points of the metabolic distribution of the carotenoid is intake carotene could be accumulated in the skin, so that we consider the skin UV protection would be a good target for the palm fruit carotene. And to confirm our hypothesis, we made an experiment as shown here. And in this experiment, we compare the effect of a palm fruit carotene with that of beta carotene. You know, it's a typical carotenoid, and on the UV-induced skin lipid peroxidation on this 3 experiment system. As experiment 1, we are investigate about the T-bar level. As you know, it's a widely accepted indicator of the lipid peroxidation in the skin of a hairless mouse after UV irradiation. And as experiment 2, we also measure the squalene monohydroperoxide level in the skin of the guinea pig, because you know squalene is one of the major lipid class in our skin lipid in the human. And as experiment 3, we also compare the pigmentation level in the skin of hairless black mouse during the UV irradiation. This slide shows some basic protocol for the experiment 1. And in this experiment, 4-week-old female albino HR1 hairless mice was used. And the palm fruit carotene or beta carotene, we made some emulsion of this one and mixed into the drinking water at a concentration of 0.005%. And administration of this carotenoid is continued 50 weeks. And after the carotenoid intake, and the back of the skin was exposed to the UV light at the 5 to 30 minutes. And before or after the UV radiation, we measure the T-bars level in the skin, and we also measure some carotenoid content of the skin at the same time. This slide shows the carotene content in the skin of the mice at week 15. As you can see, and in the carotenoid group could accumulate the carotene in the skin compared with the control group. It could be the significant accumulation level. But as you can see in slide 1, and carotenoid accumulation level in the palm fruits carotene group is higher than that of the beta carotene group. And this slide shows a change of the T-bar level in the skin of mice after UV radiation. As you can see, before the UV radiation, and the T-bars level in the control group is higher than that of both carotenoid group. And this level is quickly increasing by the UV radiation, as you can see. But on the other hand, the both carotene group, this level could be suppressed. And at 24 hours of the UV radiation, the skin T-bars level of palm fruits carotene group was found to be significantly suppressed compared with those of the beta carotene and control group. This slide shows a change of the carotene content in the skin of mice after UV radiation. And by the UV radiation, skin carotene level is quickly increasing by the UV radiation to some control level. But as you can see in this slide, carotenoid content of the palm fruits carotene group is gradually recovered within 48 hours after UV radiation. And this result indicating palm fruits carotene intake, but not beta carotene intake, significantly reduced UV-induced T-bars level. And next, I will show you the protocol of experiment 2. And in this experiment, we use a 4 weeks female albino heart-ray guinea pig as used in this experiment. And palm fruits carotene or beta carotene was mixed in the drinking water, in this case at a concentration of 0.05, and administration of the carotene with control continued 11 weeks. And after the 11 weeks of the carotenoid administration and back of the guinea pig at exposed to UV light as the same condition as experiment 1. And before and after the UV irradiation, we measure the squalene peroxide level by using the chemiluminescence HPLC method, which was established Professor Dr. Miyazawa, Tohoku University. It's a very convenient method to measure this factor. And before the UV irradiation, we also measure the carotene and the retinoid content in the skin. And this slide shows the carotene and retinoid content in the skin of a guinea pig at week 11. As you can see, compared with the control group, and both carotene groups shows a significantly higher carotenoid accumulation level. And there is no difference was seen in the skin retinoid level among the group. And this slide shows a change of the squalene peroxide per squalene ratio in the skin of lipid of a guinea pig after the UV irradiation. As you can see, this squalene peroxide ratio is quickly increasing in the control group, but on the other hand, both carotenoid groups suppress this and evaluation. So, and this ratio of the palm fruit carotene group at the 3 hours after utilization was found to be lower than those of a beta carotene and control group. And these results indicating that palm fruit carotene intake decreased the squalene peroxidation ratio in the skin of a guinea pig. And palm fruit carotene has a stronger inhibitory effect than the beta carotene on squalene peroxidation in the guinea pig. And this is my protocol for the experiment to do. And in this experiment, we use a hairless black mass, which we are breeding for the evaluation of the skin pigmentation level. And palm fruit carotene or beta carotene was given by the drinking water, and the same condition as experiment to do. And after the 80 weeks of the carotenoid administration, and backup mice was eliminated the UV and 88 joule 8 times during the 10 days. And during the UV radiation or after the UV radiation, we measure the skin pigmentation level by the lightness using the current density method. And this slide shows the change of the pigmentation level in the skin of the mice. And as you can see, and during the UV irradiation and after UV irradiation, the lightness in the skin of the palm fruit carotene group was higher than those of beta carotene group and control group. And this is a representative picture and the back of the mice in the control group and the palm fruit carotene group at day 20. And as you can see in this slide, and palm fruit carotene intake suppressed the UV-induced skin pigmentation in the mouse. And this result seems to be well reflect the result of the experiment 1 and experiment 2. And this is a conclusion of the first part, and together with all of these results, palm fruit carotene is more effective than beta carotene as an antioxidant. And palm fruit carotene intake would be useful for UV skin protection. So to confirm that these animal study, and I hope to make the effort to investigate this kind of lovely clinical trial. And I also introduce one interesting paper which appears the evaluation and human behavior at 2011. And yes, these are picture of the one women, and the middle one is a natural color, and left one is left face picture is shows the effect of sun tanning. And the right one is shows the effect of eating more carotenoid. And the investigator of this paper and asked them guys in the United States or European country and Asian country, which face color do you like? And this paper, the investigator find out that guys in the world like a carotene color face girl. It makes some sense for the think about a new concept for some oral administration of the palm carotene as cosmetic supplement. And yes, like this concept. And let me move to the cancer prevention study result. And yes, this one is some conclusion of animal studies. In these studies, we compare the oral effect of the oral administration of the palm fruit carotene and alpha carotene, which we purify the palm fruit carotene, and beta carotene against the various kinds of the rodent carcinogenesis model. This study was started around 1990, and at this time, and cancer researchers in the world believe an anti-carcinogenic action of the carotenoid is depend on its provide-me activity. So that many researchers is focused on the beta carotene, which has the most highest vitamin A activity. But throughout this study, we could find out alpha carotene has a more stronger activity compared with the beta-carotene on the skin or liver and lung and liver carcinogenesis model. And moreover, we could also find out that palm fruit carotene has a more stronger activity than the alpha-carotene in skin, lung, and liver. And at the same time, we could also find that there is a fascinating carotenoid which have the stronger anti-carcinogenic activity as shown here. And in these results, we are focusing for the strong anti-carcinogenic activity of palm fruit carotene against the liver carcinogenesis. And we have decided to start the human clinical trial. And after the 3 years pilot study, we have decided the protocol as shown here. And this study is a randomized 5 years administration study, and for the prevention of the hepatocellular carcinoma in hepatitis virus-induced liver coliposis, and which is, as a high-risk population of hepatocellular carcinoma. And as you know, a relative risk of this situation, this population is including 7% per year. It's a very high risk level. And we are enrolling the 92 patients and divide into the 2 groups. And for the experimental group, we made a supplement which we call the carotenoid mix. It contains 10 milligram of palm fruit carotene and 10 milligram of lycopene and 50 milligram of alpha-tocopherol. And the administration of the carotenoid mix as a planning to continue the 5 years. And every month we make the diagnosis of hepatocellular carcinoma by using the dynamic CT scanning. In this study, we could observe the exciting results as shown here. And this is a control group, and includes in the occurrence ratio of hepatocellular carcinoma 23% at the 3 years, including almost 38% at the 4 years. But on the other hand, and the carotenoid group is increasing to the 11%, and this ratio could be keep until the 4 years. And after the 4 and 3 months, we could observe that administration of the carotene mix shows a significant cancer prevention action compared with the control group. And this study should be stopped, should be finished under the stopping rule of the clinical trial code. And this is the first case in the world that natural food factor shows a significant cancer preventive activity in human clinical trial. And after the stopping this study, and patient in the control people, and also underwent administration of the carotenoid mix. And at that stage, and we could not satisfy in this result, and we made the effort to find out the other additional combination food factor. And as a result, to increase the efficiency of the carotenoid mix. And as a result, we could focus beta-glucoxanthin and lactoferrin. And beta-glucoxanthin is rich in the orange of the citrus, and especially higher level and in the Japanese unshu oranges. Yes, we made several animal studies and to confirm the activity of the beta-glucoxanthin, and found out that the beta-glucoxanthin have the significantly strong anti-carcinogenic action against these kind of the animal model. So that we make some unshu orange juice which contain the 3 milligram of beta-glucoxanthin. And we also added 1 gram of the myo-inositol to this juice, because we know that myo-inositol has a synergistic effect with palm fruit carotene. And as you can see, and this orange line is some we could find out a significant anti-carcinogenesis activity of on this group compared with the control group. We could find out that the unshu orange juice increase the efficiency of the carotenoid mix. And at last, I'd like to introduce the synergist effect of the lactoferrin and the carotenoid mix. And maybe you are well known, and the lactoferrin is a transferrin family iron-binding protein, and which contains human body fluid, especially high level in the human breast milk or bovine breast milk. And maybe it was 20 years ago, and several milk companies could success purify the lactoferrin for the bovine milk. And it was normally used for the ingredient for the infant milk. And recently, but the researchers find out that this lactoferrin is a multifunctional, as shown here. Lactoferrin has various kinds of excellent biological activity. And it rarely safety compound because it contains the milk, as you can see in this slide. And researcher is the National Cancer Institute, Japan, the activity of the lactoferrin against the colon carcinogenesis, and they made a randomized placebo-controlled clinical trial using the lactoferrin, and find that it has excellent activity against the anti-cancer activity for the colon cancer. So that we made a supplement and contained 1 gram of the lactoferrin and 1 gram of the myo-inositol, and make the clinical trial and the combination with some carotenoid pills. And as you can see in this slide, and the combination of the carotenoid mix and lactoferrin could completely suppress the occurrence of the hepatocellular carcinoma. So that this result seems to be suggesting that lactoferrin is one of the best partners of the carotenoid mix. And this is a summary of my second part. And throughout various kinds of animal study and human clinical trial, we could find out that palm fruit carotene has a potential for some as cancer preventive agent. And to increase the efficiency of the palm carotene for the liver cancer prevention, and the combination with the additional and fascinating food factors such as beta-cryptoxanthin, lactoferrin, would be important to increase the efficiency of the carotenoid. And finally, I'd like to introduce you two forthcoming scientific meetings for the carotenoid. And the first one is, yes, I am a committee member of the Japanese Society of Carotenoid Research. We are planning to have a 27th annual meeting in coming September. And this conference will be held in the Mie University, which is very close to the Kansai airport. And this society is recognized as a Japanese branch of the International Carotenoid Society. If you could reach this homepage, you could obtain the important information for the forthcoming carotenoid meeting. And the International Society is planning to have the 70th International Symposium of the Carotenoid, and next year, June and July, in the Salt Lake City of Utah. And I hope to see you again at the Mie University or Salt Lake City. Thank you very much for your kind attention.
Arigato. Murakoshi-san, any question from the floor?